Hello and welcome back. My name is Vikrant Athole. I am partner of OOB Consulting and VRiddhi estimation software is being designed and sold by us. So in previous videos we have seen lathe and milling operations. In this we have segregated whole operations completely separately in a separate video, and we will be covering this at the moment over here in this session now. So we catch up from where we left earlier. Add operations. Drilling is one of the operation which has largely been used and largely miscalculated in terms of cycle time. The reason is everybody expect every time you can do is direct drilling. It is not the case. Drilling timing affects largely on the cycle time or the tool path strategy what you select. For simple example, for drilling we have is G73 high speed drilling, we have is normal picking, and then direct drilling. Direct drilling is nothing but directly you drill the drill using the feed and speed. So let us start with one of the drilling operation using is a direct drilling, then we will come to other pecking. 0.18 tool diameter is 16. We have is pecking is not necessary in direct drilling. So the very first thing it is asking is depth of the hole 51. Number of holes, if there is more than one number of hole you could put in over here or keep it one. If you have is more number of holes, then this data, that is the average distance between two holes is very essential, both for the x and y axis, because your rapid will be worked on average distance. Then if there is a pre-hole diameter, you could mention it, because pre-hole diameter will affect our costing, the calculation of scrap. Then depth of peck, first peck, second peck, this is an IJK cycle, that is variable pecking cycles, which is popular with Haas. So we'll come to this later on. So let us start with try to have this like we have two number of holes, but no XY average calculation. It is telling me to input this data. So I will switch it back to 1, calculate operations. So if we use is direct drilling, if we have is 2 through tool coolant, then we could use direct drilling. Else we will go with our conventional way, which is pecking. So this is normal pecking. It means after every peck the whole tool will retract back. So here until unless I put the peck and retract, it is not going to calculate. It is telling me what is the pecking. So since it is 16 diameter, let us take as half the depth, 8 is the pecking. How much is the retract? If I try to calculate again, it will tell me to how much I would like to retract. All the machines, if you are using scan cycles G83, then you could go to the machine parameters and check what is been fed by the machine manufacturer. So this largely depends on the complete design and the manufacturing of the machine. So if you are not sure about this thing, keep it 1 mm. Because for drill tap centers, we have seen drill tap center from Sugino and all this thing where the retract is 0.2 also. So let us put it at 1 mm as retract and let us calculate operations. Now the total time is 0.36. How much was during our this thing high speed drilling cycle? 0.35, 0.36. Now let us have a look at IJK cycle. Over here, you could literally have a pecking depth. As you know, like the first depth of pecking, you can go to almost 2 to 3 times of the tool diameter. So first depth, I will keep it 32. Then reduction after every depth, I will keep it as say 16, that is the diameter. And minimum peck, I will keep it at 16. Calculate operation. You could finish this in 0.24. Sorry. Normal pecking with variable peck. And normal pecking with no variable peck. Now let's move toward this high speed pecking. Let's see. 0.35. So your timing with direct drilling is 0.24. Your timing with normal picking is 0.36. Your timing with normal picking but with IJK cycles 32, 16, 16. 0.30, and with an high speed pecking cycle it is 0.29. So if it is just one hole, it doesn't make much of a difference, but it will make it a lot of difference if there are number of holes or more. One more important factor which I keep on telling every time, that is the Z, safe distance from where your actual drilling will start. This plays a very important role in all the operations. Let us go to direct drill and keep it 1 mm and see. First let us keep it 0 and see what is the difference. It is 0.24. If I keep the Z at 1 mm safe distance and calculate it, not much of a difference. But if I go to normal picking with no IJK cycles, 0.36. Not much of a difference out over here also. So if you are working with any of this packing cycles, you could use that. So this completes our drilling operation. So let's work with other operation, that is reaming. Boring is one of the operation. Boring, straight boring, absolutely nothing over here. Again, if the number of holes are more, then you have to keep on adding this. Okay, let's check this reaming. Same like boring, absolutely no difference. Let us check now is tapping. Tool path strategy, direct tap. That is same like what we did with direct drilling. I could use this, or I could go and peck it. If I use it direct tap, I need to key in the information 90 feed is actually the pitch of the thread. See here, pitch of the thread. 2 mm, tool diameter 20, peck, not putting peck in. Depth of the hole 51. Number of hole is 1, let's calculate on that. So you will take his total time is 15.15 minute, that is 0.15 into 60, around 9 seconds for this. If you put it in Z axis, maybe for tapping you will have to keep it in larger this thing. Absolutely no difference. If I move with pecking, peck distance, since it's 20 diameter, let us keep it a peck distance of 8 mm. Calculate operation. This is the timing difference is what you have. Again, rigid tapping over here is very essential. Let us check on this. This is 8 mm. Let us calculate. Now you see over here, I have not limited this RPM, but the process RPM is 2000. The reason behind this is we have to go back to our machine input. I will close it without saving. Yes, I would say at the moment. Yes, it is reconfirming it again. I go to this milling center which I have considered and go to modify setup. In modify setup, rigid tapping RPM is this. So whenever I will select tapping operation, it will calculate this maximum RPM that has been allowed. And that is the reason why we insist on key in all the dimensions and important factors while making this database. So I hope it is almost clear to all of you how we are going to work with the VRiddhi estimation software. I think rest of the things are very clear to all of us. So if you know machining, you could start using this software. Absolutely no issues. Do write back to us because we are very keen to know your feedback. Any kind of suggestions, recommendations, or even if you want to curse us, you could definitely do that, because the more bad we hear about us, the more we will try to improve. So that's all for the moment. With this, we cover almost every operation and setups and all this thing. You could start working with VRiddhi estimation software. And in next few videos, we are going to cover is how we are going to print estimates and analysis. That is one of the factors which we also briefly covered in our introduction video. And finally, how we are going to buy this software. So have a great time, guys, and do send us your feedback, because we are very eagerly waiting for your feedbacks. So thanks, Itan. Have a great day ahead. Thank you.